Now we're gonna switch gears away from our conversation on trends, and our second objective of the survey was to understand the challenges that instrument developers are still facing in automating their solutions. So looking at the challenges identified, we again classified them, this time into six categories. The top two categories of cost and quality and regulatory combined for 57% of the overall responses. The areas of safety and ease of use, performance and engineering, and supply chain were all lower in priority. Cost challenges made up 36% of the overall responses, which was the biggest in the challenge category. The details of what made up the cost challenges were one, reducing costs, which was the single most popular response across the entire survey. And this was identified as an industry trend towards being really driven by reduced reimbursements, which are driving the need for real cost reductions in all levels in the industry. The remaining four elements that fell into the cost category are really focused on performance improvements that can drive down the cost of the overall process through the use of automation. So reducing instrument size was defined as an important element due to the constraints on lab space. Decreasing sample size was identified as a key because of the cost of additional sample and reagent are a large part of the overall process cost. Increasing instrument speed was critical in a subset of the applications where automation is a constraint on throughput, and increasing throughput was defined as critical in the context that throughput could increase through better reliability and machine availability. So the second category in terms of challenges were the quality and regulatory, with 21% of the overall responses. This category was comprised of four main areas: supplier quality and regulatory. Both end users and OEMs were focusing on laboratory uptime, and mean time between failure is their key quality metrics, and they're driving their component suppliers in terms of return parts per million. FDA requirements were recognized as having a huge overall impact on project timelines and the speed to market. Phased regional releases were identified as a current tactic to reduce the impact, but there was overall concern with the increasing regulatory requirements from both Europe and Asia. Design reuse was identified as a forward-looking tactic to deal with this challenge. Increasing robustness was characterized as an issue of designs being able to adjust to changing customer demands without the need for redesign. And sample identification dealt with the importance of sample integrity throughout the process. Looking at the detail behind the responses, reducing cost, improving accuracy, and supplier quality and reliability commanded the largest individual votes. Reducing costs received 27% of the total votes, improving accuracy garnered 14%, and supplier and quality and reliability rounded out the top three with 9%. As we discussed these answers with a subset of the respondents in greater detail, it became apparent that there are so many elements and angles to the concept of reducing cost that we could only really characterize it as a total cost of ownership. The major elements identified were the classic bill of material costs from the OEM design or procurement perspective. Additionally, there was a lot of interest in reducing the cost per test, minimizing the amount of space that an instrument consumes in the lab, increasing the number of different tests that could be performed on a single instrument, and lastly, on maximizing the ability to run instruments unattended. All of this is geared to allow laboratories to better manage their resource costs. Through conversations with respondents, the drivers for the cost challenges come back to trends and reimbursements, and the single largest goal is to drive down the per test cost through reductions in reagent usage, and better unattended operation. Improving accuracy was identified as the second largest individual challenge by respondents. With follow-on discussion, both improved positioning accuracy of the motion control and dispensing accuracy of the fluidic system were viewed as critical challenges. Dramatic changes in requirements are being driven by the rise in use of applications that require greater precision, such as automated digital pathology, molecular diagnostics, and DNA sequencing. The declining size of both sample and reagent volumes are a driver for greater levels of precision, particularly in fluidics, with some impact on motion control. The moving trend toward diagnostic applications using microscopy and spectroscopy techniques are driving new levels of demand for precision and motion control. Now, looking at the challenge data from a different perspective based on job functions, we get some insight into the similarities and differences relative to the population as a whole. The technical decision makers came in with reducing cost and improving accuracy in the number 1 and number 2 position, just as the total population had, with very similar percentages in the votes. Increasing robustness moved up from 8th position to 3rd among these technical decision makers, indicating the group's critical view of uptime and the ability to improve the process in the future without actually changing the hardware in the design. The business decision makers matched their top 3 to the overall population top 3, with improving accuracy moving from the 2nd to 3rd position, and supplier quality and reliability moving from 3rd to 2nd. Not surprisingly, this highlights the group's priority on cost and quality over the more technical attributes of the instrument. So when we commissioned this survey, our number 1 priority was to gather feedback and insight from our customers, the OEM developer. Additionally, though, we wanted to get input from the end user, the instrument user, who at the end of the day is the customer of our customer. And so we're going to take a look at some of the specifics that we saw from that data set. So from this data, from this feedback, we'd intended to use it to identify opportunities that exist for us to help the OEM satisfy their customers in ways that they might not initially see. So instrument users are the companies that are using laboratory automation and diagnostic instruments in their normal course of business. The end users shared the same view of the top 3 trends that the entire population shared. Modular automation maintained its number 1 position with a relatively similar percent of the voting. Lab on chip ranked 2nd with this group compared to 3rd of the overall population, and miniaturization moved down to 3rd. Modular automation was seen by this group as providing more robust performance, better serviceability, and more walk-away time for laboratory technicians. Lab on chip ranked high because this was one of the disruptive technologies that the end users had real exposure to and could see more immediate benefit to. The end users again shared the same view of the top 3 challenges that the entire population had ranked. The big difference here is how strongly reducing costs was identified as the biggest challenge affecting automation. Looking at the overall data, the remainder of the population put more of their voting weight into challenges that align as solutions to the challenge of implementing automation, where the end users were not as concerned with how and more focused on the financial opportunity that automation presented their business. In talking through this point with some of the end users, they were less concerned with the price of the instrument and more concerned with the value of performance, where they were defining value from a per test and a per square foot perspective. They see these instruments as revenue generators, so the more revenue they can generate and the lower the overall cost, meaning both the cost to operate and the cost to acquire, the better their financial model.